Okay, so this is the grand finale of all your hard work in section or chapter 2. And this problem's kind of long, so hang in there. In this one, we need to find the greatest possible percent error of a certain situation. So let's just read it first. Read along with me. It says the diagram at the right, this thing right here, shows the dimensions of a gift box to the nearest inch. Its measured volume is 360 inches cubed. So this is the volume. And the greatest possible error in the volume is about 24%. If the gift box's dimensions were taken to the nearest half inch, how would the greatest possible error be affected? So what it means by nearest half inch is that our dimensions right here, let me circle them in red. These measurements could be off by a half an inch. So this measurement right here, 4.5 or 5 inches, could be 4.5 inches, or it could be 5.5. So it could be off by half of an inch either way. So it's wondering what's the greatest possible error that could happen if all the measurements were underestimated by a half an inch or overestimated by a half an inch. So over here I drew two diagrams, and we have, let's do under, and then this one's going to be over. So on the left here, we're going to do what would happen to the volume if we underestimated by half an inch. Over here, we're going to do what would happen to the dimensions if we overestimated. So let me do the overestimation in green. So if the original is 5, then that means that it could have been 5.5. And if the width was 6, it could have been 6.5. And the original was 12, so it could be 12.5. Okay, so now we need to solve two equations on using the under and over. So we need to find the volume of these two situations. Well, the volume of, I guess you would call a box here, is length times width times height. So let's fill those values in. So volume of the underestimation is 5.5 times 11.5, times the height, which is 4.5. Okay, and we're going to do the same thing with the over on the right hand side. So we got volume equals length times width times height. So volume equals length of 6.5, and then the width is 12.5, and then the height is 5.5. So then we just need to punch in the calculator these two equations. So we have 5.5 times 11.5 times 4.5 equals 284.625. Okay, so this is the new volume if we underestimated the dimensions of the box. So let's do the overestimation. 6.5 times 12.5 times 5.5 equals, whoops, did I do something wrong? I think I might have calculated wrong. Let's try that again. So 6.5 times 12.5 times 5.5 equals, 446.875. Okay, so that's inches cubed. So we have an underestimation and an overestimation, and we need to compare this to the original volume of 360 inches cubed. So this is where we need to bust out our percent estimation equation thing. So that was the actual minus measured divided by measured. Alright, so our actual is always going to be 360 inches cubed. So let's write that here. Okay. So if we do this equation, we're going to do, hold on, would that be the actual or measured? Do they say measured? Its measured value is 360. Okay, yeah. So the 360 is the actual measurement, and oh, hold on. No, the 360 would be the measured. I'm sorry. It says it right in the paragraph, right? So our actual measurement, let's say it was off and it was actually 284. That's a 4625 minus 360, and then that's divided by 360. Okay, so that would be a grand total of 284.625 minus 360 equals negative 75.375. Divided by 360. Okay, and remember that the absolute value sign turns any negative into a positive. So we got 75.375 divided by 360. So then that is going to equal 0.209, which, remember, to turn this into a percent, move the decimal 2 places. So that is 20.9%. Okay, now we just need to do that for the right side. We have the actual is 446.875. So this is for our overestimation, and the measured is 360 divided by 360. Alright, get our calculator out, and we have 446.875 minus 360 equals 86.875 divided by 360. Now we need to take that number divided by 360, and that equals 0.241. Change that into a percent. So the biggest percent error in the measurement would come from an overestimation of a half of an inch on all the dimensions. Now we need to compare this 24.1% to this. So unfortunately, if we overestimate all the dimensions by half an inch, we would be over. So overestimation would be more than the allowable limit. So that's a lot of work, but you guys can do it, and just try it yourself, work through the problem step by step, and you'll get it. Once you're done with all of this, then try out the quiz and test your own knowledge there, and then I'll see you in chapter 3.